This is part 2 of the acids and bases video. So let's look at strong acids and weak acids. Here we have hydrochloric acid is a strong acid, sulfuric acid and nitric acid. And then ethanoic acid and oxalic acid are the weak acids. And then strong and weak bases, we have the sodium hydroxide and potassium hydroxide as strong bases. And then we have ammonia, calcium carbonate, potassium carbonate, and sodium hydrogen carbonate as weak bases. And now we're going to look at, you can be given this formula. These are the acids formula and the bases formula. So HCl, H2SO4, HNO3, H2C2O4, H2SO3, H3PO4, CHCOOH, and H2CO3. So those are all your bases and your acids formula. These are all your acids formula, and these are all your bases formula. All right. So when you see H3O, those are acids, and the HO with a negative on top, this is a plus, and this is a negative. This is the base, and these are acids. So we can react this with this, acids react with water, right? So we're gonna have H3O. This acid will donate its H to water to make it H3, and then we'll just have NO3 this side. So the acid will always give water its H. So let's see if this is balanced. I hope you know how to balance an equation. We have 1, 2, 3. We have 3 H's this side, and then we also have 3 H's this side. So this equation is balanced. All right. So we have H2SO4. This is an acid. It completely reacts with water. So we're gonna have H3O plus SO4. It becomes negative, and we have to include the negative there. This one becomes positive because it's gaining the H. This one, it's losing something. So we have 2 H's here, right? So all these H's, a base is a H donator as well. So it donates, an acid donates H. So it has to donate these 2 H's to water. So this equation is not balanced if you look at it. These are, we have to add another water that will take the second H. The first H is already here, so we're just gonna do, so we have 2 waters to take over the 2 H's here. So this is how you balance this type of equation, chemical equation. You balance it by putting 2 because we have 2 hydrogens there. Again, let's look at HCl plus H2O. HCl is an acid. An acid donates oxygen to water. So we're going to have H3O positive plus Cl that is negative. I hope you get this part, guys. All right, this is the other one we have. It's still a base. So we're going to have H. We'll just take this H, because if we take this one, this equation is not going to balance. I'll show you how. So we take this H3O only from this COOH, and then here we'll have CH3, COO negative. This will be positive. So we have 3 here. We have 3H. This is 4, 5, 6. So H is 6 here, and here we have 3 plus 3, H is 6 this side, so it's balanced. But if we had decided to make this a 3 and this a 3, O, it's gonna be C, C, O, O, H, like that. We're gonna have, this is, you see, 3 H's times this one, that's 6 already, and this, not 6, it's 9 actually, and this, it's 10. So this is not going to balance. Let's look at bases as well. So bases do not ionize, meaning they do not mix with water. So we're going to have Na positive plus OH negative. This is how we do it. So everything is balanced. And then here we will have the Mg plus the OH. So the base is a proton acceptor, is a valency acceptor. So this is a valency. So we'll just write it there. This is where we'll write the valency. It's a plus 2 there. But as you look, this OH, it's 2. It's not a balanced equation. So we're going to add 2 to balance this equation. You can pause the video and do this one. So we're going to have K plus OH. So when you look, this is balanced. See you on the next video.